welcome you to the 52nd lecture of NPTEL online certification course Drilling and Blasting Technology. We are discussing about special blasting techniques. This is the third topic of the special blasting technique, where we are discussing underwater blasting, and we have already discussed about the underwater blasting in the previous lecture. So, this is the second lecture of underwater blasting. So, let us retrospect so far what we have covered. We have covered the basics of drilling and blasting technology. We have understood the how the explosive is interacting with the rock and fragmenting it. We also understood the different blasting results, powder factor, rock fragmentation, etc. And we have solved a number of numericals related to the performance of the blasting, cost analysis of the blasting, and we have understood the how the rock mass properties are influencing the performance of a blast. After that, we are discussing about the special blasting techniques. We have so far we have covered ring blasting technique, HCR blasting technique, and now we are discussing about the underwater blasting. And in underwater blasting, we have already covered one class on this, and in that we have discussed some part of the underwater blasting, where excavation is carried out under the deep water condition like sea and lakes, etc. And we have discussed the methods of underwater blasting. We have seen the underwater blasting is carried out in three ways. Either we fill the underwater area, that means lake, etc., and then we carry out blasting by carrying out drilling through that filled part. So, that is one condition. In second part, we carry out the drilling from the floating pontoons or ships and carry out blasting in underwater condition, and in third cases we send the divers, etc., to carry out drilling inside the below the water and carrying out blasting using those divers. So, so far we have discussed about the rock filled condition. Now, we are discussing about the underwater blasting conditions, where we have to carry out drilling from the pontoons or rafts or say ships, from where the drilling has to be carried out. So, in this case we are having floating structures. It may be self propelling type, it may be a towing type also. So, this type of structures, generally pontoon or rafts or ships are used, and then the blasting is carried out by sending the divers, sending the explosives. So, this is the different figures where pontoons and rafts are used, and from there you can see the drill bit. So, this is the drill bit. So, this drill bit is basically carrying out the drilling. So, there are 3 drill masts in this case, which is basically carrying out drilling below the water. So, here it is one mast, there is another mast which is basically carrying out the drilling. So, the basic theory is that floating pontoon, then drill mast is there, the drilling is carried out. So, initially the drill rod is moving through the water, then it is struck onto the surface of the bottom, that is the bed of the water body, maybe sea or lake. Then the drilling is started on the bed, and then the drilling is progressed up to the desired depth, and then the blasting is carried out. Now, there are many problems occurs here. If it is explained in a nutshell, the process is like this. This is the floating pontoon, and from here this is the drill machine, and then drilling is carried out. So, this is the water and this is the bed rock which has to be blasted. Now, in this case we have to carry out the drilling in the similar way. The drilling is made in the surface bench or any other places. Then we have to place the explosive and the connected explosives from the pontoon itself. We allow the person to be stranded here, and then we withdraw the drill rod and carry out the blasting. But there are many challenges in this operation. Before that, let us discuss the advantages of using this one. Here the persons, the experts, that most of the operators, drillers, etc., are standing on the pontoons on the surface. That means we can use an expert person as the driller and expert person as the blaster. Those can be possible, but in the other cases where the divers are allowed, say divers are the having separate excellence in diving only, but they are not the expert driller, they are not the expert blaster. So, that is why this is the expertization is lost there, but in this case we can enjoy the expertization. Second one is that the visibility of the water, it may be muddy water, it may be whatever is the water condition, that visibility is not affecting, but if the water is very dirty enough, then it is very difficult for the blasters also to see the divers also to see the whole position, to carry out charging. But if it is carried out from the surface itself, the visibility of the water does not affect the water, and the divers requirement is very less. So, the cost is not significant enough, and we can use heavy machinery as the drilling also. So, that is why these are the benefits if we are carrying out these operations from the surface pontoon or so. But there are many disadvantages. We will discuss these disadvantages, but this is one we are having one drilling video. This is taken from the YouTube. This is not for the blasting purpose, this is for the deep oil rig. So, this deep oil rig where very deep drilling is carried out, and this is the floating platform from where the drilling is being progressed. Before that, the sea bed is basically, you can see the sea bed is 9,000 feet below, and the bed structure is basically first identified. So, this is the seabed structure which is identified using some geophysical technique, and after that the drilling is basically carried out. So, you understand, as it is a oil rig, it is an oil rig, very deep drilling has to be practiced here. So, it is almost 3000 meter has to be drilled. So, a big drill rig is basically utilized, large dia drilling has to be carried out. So, this large dia drilling using a casing is basically placed, then the drilling is carried out. Okay. So, after this carrying out the drilling, the casing is basically placed, and as the casing is placed, after that a little bit smaller dia drilling is basically practiced. And in this oil rig, you understand the loss has to be controlled significantly. So, for that, to control the loss, basically the bentonite or other flushing media are used, so that any cracks in the whole wall can be sealed and loss can be reduced as much as possible. So, you can see the shielding of the whole walls, sealing of the whole walls is carried out, by the different flushing medium, and by this way the deep drilling is basically carried out for the oil cell. But for blasting it is not required, that much accuracy, that much costly drilling system is not required, that much deep drilling is also not required. Generally blast hole in the sea water in general not exceeds 10 meter, 3 meter to 10 meter drilling lengths are used. Generally single casing is good enough, and casing is kept remain intact throughout the blasting process. Now, let us understand what are the challenges in this particular system. The challenges in this particular system is that always you will find out in any water bodies, if these are the beds, then before these beds some siltation occurs, and these siltations are basically the sediments, those are loosely occurring there, it is something like slush etc. So, what is happening, the moment a drilling is carried out, here, then this slush is coming into this drill hole and choking the drill hole. So, this is very difficult condition and that must be overcome. So, whatever is the slashes at this position, that will try to enter into the holes and choke the holes. So, to avoid this one, the requirement is that when the drilling is carried out, the casing is provided to resist the slashes to enter into this, and the casing will kept at that position throughout the drilling. After the drilling, generally drill rods are not withdrawn, only the bits are withdrawn, casing is kept intact at that place. There are two ways, one is that divers are allowed, to place the explosive inside the hole and charge it, then allow the casing to come out, or if the casing is not iron made or so, if it is flexible one, then the casing may be blasted also. Otherwise, casing is withdrawn once the charging is placed, then the casing is withdrawn and then the blasting is carried out. So, casing is kept intact, then the charging is made, then the casing is withdrawn, then the holes are stemmed and finally the blasting is carried out. So, the keeping the hole intact is very difficult one, and that is the difficult part, and the complete blasting team has to take care of this one. This is the first challenge, that the underwater blasting from the surface. Second challenge is that the integrity of the drilling system. As this drilling is carried out from a floating device and there are waves, as it is sea or lake, big lakes, there are waves that is trying to oscillate the floating structure. So, this oscillation basically keeping the integrity of the drilling system. So, the holes are deviating, holes may be lost, drill bit may be broken, the positioning of the hole is very difficult. So, all these problems, drilling is really a tough job from a unstable platform to the bottom part, and using these heavy machines are very difficult condition. So, that is why this job is really challenging, and the integrity of this system is really a very challenging one, and the complete job is a really tough job. However, once the drilling, you see the drilling means you cannot withdraw the drill unless and until you charge that one. So, the complete system. So, this is once the drill hole is made, you have to charge it, then you have to remove it, and you have to this intact wire you have to taken out from the hole. So, that is why this charging you cannot withdraw the drilling system unless and until you complete the charge, because the moment you will withdraw, the slush will enter into this. So, that must be keeping in mind this control over the drilling and blasting is very, very important while this is carried out from the surface itself. Now, is the last part where the drilling and blasting is carried out using the divers. So, in this case we send the diver will go and carry out the drilling manually. We give the compressed air source to the drill machine, we give the oxygen source to the divers, so that the continuous drilling can be carried out, and after carried out drilling a number of holes, the same driver will basically charge the hole and then blast the hole from the surface itself. So, here the problem is that our diver engagement hours are high. So, that the cost of blasting will be very high and will lack in the expertization. The diver is not very expert in the underwater in drilling, the diver is not expert in blasting also. So, solely his decision on placing the holes etc., may not be justify the proper blast design, but anyway the experts cannot enter into that. So, the system is very, very difficult one. The improved system is possible where the underwater machines can be used, which can propel into the underwater conditions reached up to that particular place, which may be compressed air driven or so, and carry out drilling remote controlled, carry out drilling in that particular position, and then the divers will be allowed to go for the charging. So, this automated device compressed air operated device drilling machine can be used, which can be remote controlled and can be used for the underwater blasting. Now, Gimeno et al. Has given the basic understanding of the underwater blasting. Generally, in underwater blasting, the design criteria is little bit different. Here it is similar condition to the underground blasting, where only single free face is available and benching is not there. So, that is why the designing is has to be carried out a little bit of crater blasting condition, considering the crater blasting conditions, and that is why the powder factor may be little bit high and it may go up to 0.5 to 0.3 kg per meter cube. So, these holes will be placed in such a manner, so that the fragmented boulders should be of size that one which can be easily handled by the dredger. So, that is the requirement in the design guideline. So, this design consideration is basically considering that the complete water, then the sludges or the loose material or silts which are available above the rock and the rock, these three are combined to consider as one material, and it is considered the complete the explosive charge which is placed is basically the blasting of this complete material, water, sludge and rock. So, the equivalent height is considered, that means equivalent height of the material having the density equal to the rock, that is considered. So, let us consider rho A is the density of water, H A is the height of the water. that is this one, and HMR is the height of the overburden or sludge, rho mr is its density, and for rock it is HR and rho r. Now, we are having material of HA into rho A, that is the impedance, HMR into rho mr and HR into rho r. So, these are the impedance of water, then your overburden and rock we are basically considering. So, these are the three system available. Now, we are as we are converting it equivalent of the rock. So, basically HE into rho r. So, this is equivalent to a HE rho r of thick bed, that is considered. So, the equivalent height HE is considered as the rho A into HA by rho r, rho mr into HMR by rho r and HR. So, this is HR is this part, HR into rho r by rho r. So, rho r cancel. So, this is the equivalent height of rock bed is considered in this case, and we consider the blasting is carried out in this rock bed. Now, the powder factor is decided using this formula. This is the 0.5 as the constant is considered, plus 0.1 for each, that is the crater blasting height is considered, and which is multiplied by the equivalent height. So, this is the considerations of the charge factor which is considered for this particular case, where we are having the rock depth, we are having the slashes depth, we are having the water depth. For that, how the charge factor is considered, that guideline is basically developed in consideration of that one. So, this is 0.1 kg per meter cube per meter of, this is the charge factor for per meter of rock height is considered, which is basically similar to the rock factor generally considered in the blasting. Now, based on that, Gimeno has suggested the powder factor and the sizes of the block size for considering the bucket dredger. If it is the maximum allowable block size is 60 centimeter, then powder factor varies from 0.5 to 3. For cutter section dredger, if the maximum block size is 30 centimeter, then it is 1. Crab dredger 30, then it is 1. Deeper dredger, if the maximum block size 80, then it is 0.5 to 2.5 kg per meter cube. That is the guideline given by the Gimeno in his book in 1995. So, powder factor basically considered as the function of height of water, height of slash, height of rock, density of them. The blast hole diameter, a guideline is given by the Gimeno, considering the height, bench height in the rock, it is not H, it is the HR basically, considering what should be the diameter of the drill hole. That guideline is given by the Gimeno. Linear charge concentration is considered as a function of say explosive pressure, detonating pressure of the explosive, explosive density, diameter of the hole. The linear charge, that area of average breakage is considered, can be calculated using the linear charge concentration by the powder factor, which is decided, and drilling pattern is considered as the root over of area, because the square pattern is used. As the square pattern is used, so basically it is considered if the drill hole is at this position, it is basically creating an excavation of this one. So, that part is basically excavated. So, it is burden, it is spacing, it is burden. So, B into S. So, as it is b square, this square pattern, b is equal to s. So, it is b square or a square. So, that is the A. So, that is the fractured area, zone of fracture zone. So, that is considered as the fracture zone. So, that is why these considerations are used. Subdrilling is the requirement which is for square pattern is almost equal to the B, but considering the angle of breakage 90 degree, these are the different subdrilling is considered. That much deep subdrilling has to be carried out to achieve the proper fragmentation. So, if the breakage angle is 70 degree, then it is B for square pattern, if it is more, then it is reduced accordingly. For staggered pattern, obviously the breakage angle subdrilling requirement is little bit less. So, the volume of blasted rock, if the is known, that is the this is the area. So, this is A and this is up to the depth. So, if we are looking at the section, and below this is the subdrilling. Okay. So, this is burden, this is H, okay, and this is J, subdrilling is J. So, here we have considered a breakage angle. So, this considering that, we consider it is one third of this area will be broken for this portion. So, here we achieve a little bit breakage like this. So, this breakage area is basically one third of that one is basically achieved. So, considerations of that is basically, so this is actually one third AAJ is basically the cone we are considering here. So, this is the cone we are considering here. Actually, this will go up to this one. So, this is the cone we are considering. So, this cone one third AAJ as the portion for this subdrilling, and rest part is the AAJ. So, that is considered here, and with this considerations this volume is basically obtained. So, as we know the volume, we have already fixed the CE. So, the total charge quantity can be obtained from there. CE we have fixed from that equivalent height that we have fixed. So, from there we have get the QB, and the length of charge can be obtained by providing the QB by QL. Okay. So, that is already known to us. So, again we can show you the linear charge concentration. Okay. So, that is known to us, that is pi d square by 4, that is the linear charge concentration into rho. Okay. So, that can be achieved. So, we can write here also QL is equal to pi d square by 4 rho E is the linear charge concentration is already known to us. So, now this is the stemming length. Stemming length is the complete drilling length minus the charge length is basically gives us the stemming length. Generally, we must see it should not be less than 50 d or 50 centimeter, that must be considered. So, considering this, let us consider one problem where we can have a rock bench of 5 meter has to be blasted and water cover is 10 meter is given. There is no height of HMR, actually no slash is given. So, we are not considering that. Drilling diameter is given 51 mm and the explosive density is given already, and rock density is also given. Okay. Now, we can understand from here we can get pi into 51 divided by 1000. So, that square pi by 4 into 1.3 into 1000. So, that will give us the QL. So, QL is now known to us. Okay. Now, let us try to solve it. So, our first is that we have to find the HE. We are having HA given 10, HR given 5, HMR is not given. So, we are not considering this is. So, this is rho of water is considered 1, rho r is 2.5. So, considering that, our HE is equivalent height is considered as 9 meter. Now, we know the powder factor. Here powder factor we have placed this one. So, we have obtained 1.4 kg per meter cube is the powder factor should be provided. We have already obtained from this one. So, we have calculated this is 2.66 kg per meter is the linear charge concentration. So, this is now I think you are able to understood how to use this one. If some HMR is given, that has to be considered, but in this present problem HMR is not given. So, we have not considered that one, and rest part we have considered as this and calculated this one. Now, let us move to the next part of calculation. Now, we have to find out the area of influence. The influence of area is QL by CE. So, this is the influential area, because QL is not, that is for 1 meter height. Okay. So, this is kg per meter, this is kg per meter cube. So, the meter square area, that influential area of that particular charge, that is QL charge, what could be the equivalent area, surface area, that has to be considered. So, for that we are calculating this one. So, this is 2.66, this is 1.4. So, we have got 1.9 meter square can be the area. So, as square meter burden into spacing square, we are considering burden into spacing. So, that means burden square is equal to spacing square is equal to 1.9 meter square. So, that is coming around burden is equal to spacing is equal to 1.38 meter. So, this is the square root of 1.9, that is giving us the 1.38 meter is the influential area. So, burden is now known to us, 1.38 is burden, 1.38 is spacing. Now, we have to find out the subgrade drilling requirement. As the table is given, the table full table is already shown you. We have considered the breakage is at 70° angle for the sub drilling part, considering that 70° angle. For the square pattern it is B, for the staggered pattern let us consider we have used staggered pattern. So, it is 0.9 B. So, 0.9 into 1.38, that is coming 1.24 is the sub drilling. So, here after drilling a sub drilling of 1.24. Okay. So, 1.24 meter sub drilling has to be practiced here. So, our total drilling depth will be 5 plus 1.24. So, that 6.24 meter below rock we have to drill. So, that is our drilling length. Now, we have calculated here. So, now as we know the subdrilling, we can calculate the volume of rock. So, the volume of rock can be calculated as the area into height for the part up to the above the bench height, and below that the crater part is basically the 1/3 of that one as a cone. So, the subdrilling part. So, it is coming 10.28. So, it is coming 10.28 meter cube is the total volume of rock, and as we know it is 10.28 is the total volume of rock. The quantity of charge required is basically the volume of rock by the powder factor. Okay, sorry, it is multiplied by the powder factor. So, that is 1.4 is our powder factor, and volume of rock is 10.28. So, every hole we have to place the 14.39 kg of explosives. So, this is kg per meter cube, this is meter cube. So, this meter cube will cancel, and this is the kg we can obtain. So, this is the quantity, this is the quantity of explosive we have to place in the hole. So, we can find out the charge length L is equal to q b by q L. So, that will give us the charge length. So, considering that the charge length is calculated as 5.41 meter. So, among that 6.24, this is the rock cover, this is the subdrilling minus this is the charge length. So, the stemming of 0.83 meter has to be placed, this is meter not centimeter, has to be placed, which is coming around approximately 16 D. So, our requirement is 15 D. So, that is fulfilled. So, that is why this is the excavation, this is the stemming has to be provided. Now, considering this, now we are having the complete drilling and blasting pattern here. Say this is a 10 meter water column, below that we are having 5 meter rock. So, we have to carry out a drilling of 6.24 meter, in which we have to place, this is 1.24 meter, we have to place 5.41 meter and this is 0.83 meter stemming, and after blasting we are expected that we will, if this is the volume, we are expecting that we will achieve an excavation of volume equivalent to this much. So, this is our designing of the underwater blasting, and that can be practiced. Now, what are the impact of this underwater blasting? One is that this underwater blasting we cannot have very good stemming, because it is very difficult to carry out stemming below the water, and that is why in this difficult condition the generation of shock wave is very high, and the instrument which is basically monitor the vibration in the water is called hydrophone. So, this is a schematic picture how the hydrophone works. So, this is basically measure the vibration inside the water because of some other wave generator. So, here the explosive which generates shock wave. So, that shock wave basically generate vibration. The problem is that generally most of the living species they cannot withstand this shock wave, and that is why often the blasting when it is carried out below the water, huge quantity of the sea species like fishes etcetera died under that vibration. So, that is the main drawback of underwater blasting, and you can see huge quantity of these fishes die after each blast. So, that is why that is a big problem in the underwater blasting, especially the generation of the shock waves. So, this is more or less about the underwater blasting. We will continue with the drilling and blasting technology. Thank you.